Hey guys, I'm back. Okay, I pulled up the latest GOES 16 East run and full disc. Got it on the natural color, UMETSAT. It's like another satellite, I guess, up there in this geosynchronous orbit that coloradostate.edu accesses on their RAM slider Sierra site. Anyway, here's what I found. Check this out. It's showing up later. Any visual evidence of it, the light beam. Pretty sure yesterday it was, even yesterday. Okay, I pulled up yesterday, I'll show you that in a second. But let me finish this point here on today's run. So there it is showing up 4:15, 4:30, and this is around 10 or 11 p.m. Eastern Daylight Time. 4:45. As you can see, it goes through the shot without any pixelation. Here's yesterday's video. Watch this. Okay, still same 4:15. The light beam looks pretty similar. But look, catching some pixel action there. And we're not catching it on here. So I would suggest to me that it's getting further away from the satellite. So they're having to do less to cover it up. And to further illustrate that point, this is the original one when I found it. This is before I discovered the UMETSAT. You can see the pixelation's pretty high up on the globe. This is on the GOES 16 on 1017. UTC or 1017. That's 5. So the times are pretty much similar to when it crosses in front of the satellite. So that's the 1017 one. So you can see it's a lot closer to the satellite. They're having to pixelate a lot more stuff out. And then this one's on 1018. Same deal. You can see it's a lot closer. So that would suggest to me that it's getting further away from the satellite and therefore most likely closer to the Earth. We'll monitor that. We'll check it out tonight on the Himawari feed. Now I pulled up ACE again, of course. This is the last 7 days, just to illustrate the point I was making yesterday about those gaps going away again. We got some small gaps here, but nothing like the 8 or 9 hour gaps we were experiencing around the midnight hour each day. And then I pulled up Discover to see if it was still online. It's not. So here's the Discover run, but really it's ACE. It says they dial it back down whenever there's data outages or whatever, and then they revert back to the ACE feed. And then this is the ACE feed showing up on this display, which is a little better and easier to see. And there's the gaps. They're only a couple hours at most. And then we got gap, gap, so there's an object, no object, another gap, and then nothing after that. So let me dial it back to 24 hours. Whoops, that's 6 hours. Okay, 24 hours. Now you see how we get all these thoughts everywhere? You know, why is the solar wind being disrupted like that? The density, along with the speed too, and the temperature. All these fluctuations. So going back to my point yesterday, I think whatever planet that passed by that was blocking the data on ACE passed by, and it has a magnetosphere similar to the Earth. And you see all the polar cap field lines streaming away from the planet. This is the latest ISWA run, last 300 frames. These three are synced, and these are the Fock radiation belts. These are the electron counts, slowest moving electrons, lowest energy electrons. At the lowest electron count, 10 keV, and these are the highest high energy electrons at the highest electron count of 4,000 keV or 4 MeV. So these two are synced. These three are, and they roughly run together when I play them. But anyway, the planet that passed by ACE has a magnetosphere, probably. Most planets do, actually. There's a few in our solar system that don't, but I believe most do. So here's my theory. These field lines that are around the magnetosphere, they're causing the disruptions. And then you go here to geospace. This is the latest model, and you can see the pressure is almost back to total equilibrium again between the backside pressure from Nemesis and the front side pressure from the Sun. Here's what I want to show you, the density. Now look at all these waves of density coming in on the magnetopause. And this is like the last 4-hour run, 3+ hour run, starting around 8 UTC. Or 9 something UTC, so that's like about 3 in the morning Eastern Daylight Time. So you see what I'm saying? All these waves and waves and waves of density. But then up here, so this is a 1-day run on ACE displayed on the Discover satellite website. You can see what I'm talking about, all these variable densities. But as you can see, it doesn't fluctuate that much. And not only that, the wind speed's quite constant. So the only thing that I can figure that would account for the way this is all broken up looking, and the way that we're getting wave after wave of fluctuating solar wind coming from the sun side, to me would have to be a large planet that passed that was creating 8-9 hour gaps for 6 months on ACE, which finally passed, and then it's been blocking the data on Discover. So I pulled up their data feed again, and this is for the last 7 days. You can see this is when they went offline completely. They switched back to ACE. We had no data on the 25th. Then yesterday, for some reason, they popped on with some, well, actually that was yesterday's here. So yesterday they popped on with some data. Guess they picked up some here. But now, once again, they're reverted back to the ACE satellite because we got no data coming in from these collection points on the Earth. So my hypothesis would be that that large planet and a couple ones that were trailing it that left us last few gaps, the last few days, they left a few of them gaps. It's now blocking the data collection from ACE or from Discover. So they're not getting the relay between Discover and the Earth because that big planet's blocking. So I put the hypothesis together about the planet passing ACE and all that, and blocking the data relay from Discover to Earth underneath in the comment section yesterday, and I'll just copy and paste that and put it once again under this one. So we'll just play this last part of this movie out. Let you see the run through on last 300 frames on ISWA. You can see the magnetoposit getting all crumpled up. But once again, the solar wind speed is rather constant, and it's actually below average. The average is 400 to 700 kilometers per second. Density is average is between 4 and 6 atoms per cubic centimeter. So you can see that's for the most part running pretty low. The phi angle, that indicates the connection between the Earth and the Sun, would be at 180. Anything above 180, well, it's a Sun-Earth connection at 180. Anything above 180 is something behind the Sun, a solar body connecting with Earth. So this was yesterday. This is a one-day run on the data. You can see most of yesterday, at least from 1400 hours up until about 0500 UTC. We were connected to, for the most part, Nemesis or Hercolubus, whatever you want to call it, behind the Earth. Then we went back to a Earth to Sun connection, and you can see that in the tutorials I put in the description box. Just click on the solar hymn tutorial in the description box, click on the Lagrange point diagram. I mean, I got a lot of good info in that description box. Those two in particular, I would recommend accessing. And you can access the latest GOES 16 or Himawari link, whichever the video applies to. So anyway, here's the latest run. You can see the planet's still under great distress, great pressure from both sides, back and front. There's the closed field lines, the black ones. Normally they just stream away from the planet. No, they're not the polar cap ones, rather. They're not the closed ones. The red ones are closed. And they only close whenever there's too much solar wind pressure coming, that they have to close up and buck up and garner some energy from the Earth to try to expel all that extra pressure and that extra electron energy. I think that is most likely weakening the magnetosphere, as the Earth's been having to expel having to make some Herculean efforts to try to expel all this stuff that's coming at it from the backside. So you get the backside bow shock built up wherever those lines are. Can't see them there. There you can see them. And well, the blacks and purples are back a little bit. Those would be super high energy electron counts. Whenever you see the white, I think these electron counts are so energetic and so high that this isn't able to read them, so it's just showing them in a whiteout position. Look at that, how the field lines have to ball up in the red to expel all that energy. There's really not much any missing time on this run. And this solar wind speed number, that's coming all from these satellites in geosynchronous orbit around the planet at 22,236 to 41 miles above the Earth. And that's where the satellite is, where we're catching the view. Catching the view of this object. It's at that same orbit position. Well, I'm running out of time. God bless. Peace, and I'm out. See you later today.